Hi everyone, today's topic is solving systems of equations using the graphing method. As a reminder, you do not need to write down everything we cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you got it. Just be careful, make sure you don't fast forward too much that you miss out on something important. Let's get started. As a review, a system of equations is when you have two or more equations working together, so the solution you're trying to get is going to be the one that works for both of them, and you're going to be working to get the answer for two different variables. So that's why whether you are solving the system of equations algebraically or graphically, you're looking for an ordered pair, the x and the y value, the xy point. Algebraically, you're looking for the xy ordered pair that's going to work for all the equations in the system, meaning you're going to get a true statement when you plug it into the problem. And graphically, it's going to be the ordered pair, or the point, where the equations will intersect or meet on the graph. So today we're talking more about the graphing method. And here's an example of what that's going to look like. So if you have a blue linear equation line meeting with the red linear equation line at the point xy, then that point xy is your actual solution. Make sure you jot this down. There are three total methods that we are going to cover on how to solve a system of equations. There's the graphing method, the substitution method, and the elimination method. And today we are just going over the graphing method. So make sure this is in your notes so you keep track of each of the methods. All right, here are the steps for using the graphing method. It's quite a lot, but we're going to go over some examples so that it makes more sense to you. First step is to make sure that your equations are in y equals mx plus b form. If you haven't figured it out by now, y equals mx plus b is a very easy and useful form for you to put your equations in. So you almost always want your equations in y equals mx plus b form. If they are not in y equals mx plus b form, use inverse operations to change them so that they are in y equals mx plus b form. The reason why we want them in y equals mx plus b form is we can easily get the slope and the y-intercept from that form. And since it's the graphing method, you're going to use those two pieces of information. You're going to start with your first equation, and you're going to graph the y-intercept, or the b, first. That's where we always start off. Then you're going to use the slope, rise over run, to graph the second point. You're going to connect those two dots to make the first equations line. Then you're just going to do the same thing for the other equations. And then you're going to find the ordered pair where the equations meet. That should be your answer. Now, before you click submit or check, you want to substitute that back into each equation and make sure that it makes a true statement, or else you could have just made a silly mistake and then you're going to get the whole problem wrong. So that's why the last step is always just to check your answer. Make sure that this is in your notes before we move on, because we're going to go on to some examples now. Okay, so in this example, they are asking you to find the solution to the system of equations. And on Khan Academy, you can use the interactive graph to find the solution. So you can move these dots to make those lines easier. The first equation in your system is 21x plus 7y equals 42. The second is negative 5x plus 5y equals 10. And notice how they have a blank for x and y. So they're reminding you that you need two different numbers in your answer. So our first step is to make sure they're in y equals mx plus b form, which they are not. Go ahead and pause the video and try it on your own first. Do as much as you can. All right, let's look at this problem. I will color code my work since I have a blue and a pink, and that'll make it a little bit easier for me. So I'll make the first one blue, the second one pink, and I'll get started. So the first one is 21x plus 7y equals 42. It is not in y equals mx plus b form. So that is definitely the first thing I need to do with both of my equations. I need to get y by itself. So let me draw a line down the equal sign, and I want to get y by itself. So that means I need to get rid of this 21x and move it to the other side. Now I need to use inverse operations. Since this is a positive 21x, I'm going to subtract it from both sides. 21x minus 21x is no x's left over. On the left-hand side, you're left with 7y. And then these two cannot be combined. They need to stay separate because they're not like terms. One has an x and one does not have an x. And notice that I put it in y equals mx plus b format. I just switched their orders. And then in order to get y by itself, I need to get rid of this 7. The 7 is being multiplied, so the opposite would be to divide. And if you remember from before, we need to make sure we divide everybody on the other side by 7. So 7 divided by 7 cancels out to 1, so you end up with 1y. Negative 21x divided by 7 is negative 3x. And then this is added to 42 divided by 7, which is 6. So this ends up being our equation. So I have a b of 6, and I have a m of negative 3. Remember, m is rise over run, so I need a number on the bottom, and that's always going to be 1. So I can go ahead and actually graph this using my blue line. This is a b of 6, so it needs to start at 6. And then this needs to be moved. This is going down 3 and to the right 1. So down 1, 2, 3, and to the right 1. 1, 2, 3, and then to the right 1. Okay, so that should be my line for blue. Now I'm going to do the same thing to my second equation, which is negative 5x plus 5y equals 10. Okay, I need to get y by itself, so I need to get rid of this negative 5x. The opposite is plus 5x. That's going to cancel it on the left-hand side. And then I end up with just 5y on the left-hand side because these two cancel. And then these two cannot be combined. They're not like terms. One has an x and the other one does not have an x. So they can't be combined to like 15x or something. It doesn't make any sense. It would have to be 10x plus 5x to be 15x. Now, in order to get y by itself completely, I need to get rid of this 5. This 5 is being multiplied, so to get rid of it, we will do the opposite, which is divide. And everybody has to be divided by that 5. 5 divided by 5 is 1, so we end up with 1y. 5 divided by 5 is 1, so we end up with 1x. 10 divided by 5 is 2. So here we have a b of 2 and a slope of 1. Now we need a rise and a run, so we're going to put it over 1. So our y-intercept is at 2, and it's going up 1, over 1. Wow, it lands right on this point right here, which is our answer. Up 1, over 1. If they end up sharing that point, then that is their answer. Our answer is this point right here, 1, 3. Now, before I can know for sure if that's the answer, I might want to check it. So for the first equation, 21 times x plus 7 times y equals 42 should give us a true answer if the x and y actually do work. So this is 21 times x plus 7 times y. That's 21 plus 21, which does equal to 42. So it works for that one. Remember, it has to work for both of them. So let's try it for the other one. Negative 5 times my x, which is 1, plus 5 times my y, which is 3, should equal to 10. This is negative 5 plus 15. And negative 5 plus 15 is just like 15 minus 5, so that does work. So I know for sure now when I put in 1, 3, if I did all this checking correct, that it'll definitely say it's the correct answer because I checked it. So 1, 3, oh my gosh, it reset for some reason. Let me just do it again. So this is a y-intercept of 6, and then down 3 and over 1, and this one was 2, and then up 1 over 1, where it met at 1, 3. Okay. All right, because it's going to check your graphing and your answer. All right, make sure that if you didn't quite get that you're rewinding the video and rewatching it again before moving on. We're just going to do one more example, and then that'll be it for this lesson. So make sure that you got this before moving on. Okay, for this example, you have two equations again, and they're not in y equals mx plus b, and you're going to need to graph it to find the answer and put in your x, y answer. So go ahead and pause the video and try it on your own first. All right, let me make my first one the pink one, my second one the blue one. Remember, we need to put them in y equals mx plus b form for both of them. So let's start off with my first one. That's negative 8x plus 4y equals 24. Draw my line down there. I need to get y by itself. So I need to get rid of this minus 8x on the left-hand side. I'm going to do that by using inverse operations to cancel. So then I end up with 4y equals 8x plus 24, since they're not like terms. Then this is multiplied by 4, so I need to divide by 4 for everybody. That'll become 4 divided by 4 is 1y. 8 divided by 4 is 2, don't forget the x, plus 24 divided by 4 is 6. So this is that same equation, but in y equals mx plus b form. My b is 6, and my m is 2 over 1, because we need that value. Let me graph that on my pink one. That is 6 as our y-intercept, and it's going to go up 2 and over 1. So it's going to be this point right here. Let's see if it even lets me do that. Yes, it does. So again, the y-intercept is 6, and the slope is up 2 and over 1. Now, if for some reason you couldn't graph it, it went off the graph, you could just use the reverse. So remember, this is the same thing as the reverse, negative 2 over negative 1, because these two would cancel. So instead of going up 2 and to the right 1, you could go down 2 and to the left 1. That'll still put you on that line. So starting at 6, you can go down 2, 1, 2, and then to the left 1. That's if there was no space for you to graph it. It was just at the edge, but if it was like the point up, you would have to go backwards, and instead of going up 2, you go down 2. Instead of going right 1, you go left 1, okay? Sometimes that might happen, so I'm just letting you know in case that does happen in the future. It's not impossible, you just have to kind of use a little sneaky way around it. It's not really sneaky, it's the same answer. Okay, let's do number 2 in blue. Negative 7x plus 7y equals 28. Okay, we need y by itself. So I need to get rid of this x by adding 7x. That cancels. I get 7y equals 7x plus 28. Can't be combined. Now this is multiplied by 7, so we got to divide by 7 for everybody. That cancels. 7 divided by 7 is 1y. 7 divided by 7 is 1. Don't forget your x. 28 divided by 7 is 4. So this one is b equals 4 and m equals 1. Needs a rise and run, so you put it over 1. If I were to graph that, I would start with 4 on my y-intercept, and this is up 1 and to the right 1. Up 1 at 5 and to the right 1 up there. Up 1 and to the right 1. So it looks like they intersect at -2, which is the first number on the x-axis, and +2. So we have -2, +2. Now, you should know by now that we're not going to just say that's the answer, right? We should probably check it, because if you did all this work and then you made a silly error, that would be a shame, right? So let's check our work before we hit submit. -8, I'm looking at the first equation, times x. X is -2, plus 4 times y, 2, should equal to 24. So -8 times -2 is 16 plus 8. Does that equal to 24? Yes, it does. 16 plus 8 is 24. So the first one works. Let's try the second one. -7 times x, our x is -2, plus 7 times y, y is 2, should equal to 28. -7 times -2 is +14. 14 plus 14 does equal to 28. So when I put in this answer, -2, 2, I'm pretty positive it's going to work. And it looks like Khan Academy has a glitch where when you put in your answer, it resets this graph. So just be aware of that. You're going to have to redo that really quickly, but you already did it once, and you can double check that you got the answer, that it intersects at the right place. So the first one was 6, and then up 2 over 1, up 1, 2 over 1. The second one was 4, and this was up 1 to the right 1, up 1 to the right 1, and it intersects at -2, 2. Remember, we're pretty sure that's going to work. All right, so that's it. That's all we're going to go over today. Let me know if you have any questions as you work on these problems. Please, please, please remember to follow those steps, show your work, check your work, and you will maybe spend a little bit more time, but you will definitely be getting 100. It's a little bit more work, but it's doable. Let me know if you have questions, and I'll see you in class.